Alright, Chapter 4. Chapter 4, Completing Printed Circuit Board Design Using Orcad Capture and Layout. Introduction to Industry Standard. In the previous chapter, we looked at how you use the Orcad tool for the design circuit schematics and in the capture route with the PCB with the layout post-processing for the design fabrication of the board. We have not as yet taken a look at how to design a PCB itself. Chapter 4 and 6 provide an introduction to PCB to design. Chapter 4 introduces industry standards related with the PCB design. Not every PCB as manufacturer makes it into a service. The ratio of the number of the PCB that enters for the number of the PCB manufacturers yielded in a percentage. Higher yield, the better with the failed boards, cost time, and the money produced waste. There are several failure points that can be addressed with increased yield. To have a high yield, we need there three things. First, board has to be manufacturable. Second, to perform properly, signal integrity and quality. And third, it has to be reliable. It has to work for the full length of the expected lifespan. Being manufactured meaning two things: the bare board has been able to fabricate it given the standard fabrication allowances or SFAs. The board also has to be able to be assembled. That is part of it not being able to be attached to the board will be with its proper solder joints without damaging the parts of the board. Performance refers to as both mechanical and electrical consideration. Mechanically, with the board with a physically fit into the closure must be able to handle the environment with respect to the humidity, temperature, vibration, and humidity. Electrical performance refers to whether it meets the operational design constraints or power, I/O, etc. It is immune to outside interferences and does not cover the interference with the neighboring equipment. Being reliable means that it must have above the consideration over expected life of the device. If it has done correctly, should not fail before expected end of the life unless the user exceeds specified operational design criteria. If users stay with the operational guidelines and unit still fail, though, then there was a bare board defect. Manufacturer defect was not caused by your design, or the circuit of the printed circuit board design defect that resulted in a poor assembly process, which resulted in the damage of the components of the board, or the circuit was operating too closely, too limited for the stress system. Failed earlier due to the accelerated stressing aging. Reliability problems exist with the failure analysis of the conduct of the board is redesigned. Introducing standard organization. When you begin a new PCB design, you might be asking how big, what shape should the board outline, what should be part of the place, with what order, what kind of layer stacking should be used, how would wide and far apart should the traces be routed with the groundage of the shield technique should be used. Is there a right way to do this, or who says so? Several different standards related with the PCB design. Organizations below set the standard that maybe the guidelines, rules, certification, even law, but to cover all aspects of the standard that would fill with the entire book by itself. Some of the standard organization that may have the heard of the will or hear at least below with a brief description of who they are and what they do. The discussion chapter is limited to the basic standard of the PCB design. Listing applicable design standards is presented in Appendix B. Institute of Printed Circuit Boards, or IPC, Association Connecting Electronic Industries. Institute of Printed Circuits. Institute of Printed Circuits with a global trade association consisting of more than 2,300 member companies. It is the organizational made with the contributor of the industry that include the designer, board manufacturer, assembly company, for the supply of the original equipment manufacturer, contributing member to bring lessons learned with knowing good practice to the table, and the documentation disseminated with the knowledge based on the industry accepted standards. Over the past several years, the Internet Institute of Printed Circuit Boards standards have been replaced many by the military standards in source that you should be familiar with the list of the Institute of Printed Circuit Board standards is provided in Appendix B. You can also visit the IPC website at ipc.org where you can download the Freeland Pattern Viewer. Alright, your Electronic Industry Alliance, EIA. The EIA is a national trade organization comprising of 1,000 U.S. manufacturers, highly tech association company with the primary focus of promoting market development and competitiveness of the U.S. high-tech industry with the global economy through the domestic international policy effort. They have the influence design standard by contributing to groups which include the following: the CEA, Consumer Electronics Association; ECA, Electronic Components Assembly Material Association; GEIA, Government and Electronic Information Technology Assistant; GEDEC, Solid State Technology Association; the TIA, Telecommunication Industry Association; EIF, Electronic Industrial Foundation; and ISA, Internet Security Alliance. The Joint Electronic Device Engineering Council, or GEDEC, the Joint Electronic Device Engineering Council, known as the GEDEC Solid State Technology Association, is a semiconductor engineering standardization body of the EIA, Electronic Industry Alliance, is an association of several hundred organizations that represent the area of the electronic industry with the primary focus with regard printed circuit board design, standardizing discrete and integrated circuit for the semiconductor devices and packages. You didn't know the package specification order design the footprints for the PCB. You can also make many of the standards only with the GEDEC. .org, a list of many package specifications provided in Appendix C. International Engineering Consortium. The International Engineering Consortium is a non-profiting organization that works for the business and educational community to conduct the research, report, finding for the publication conference to address industry opportunities and challenges to aid industry and academia. You can find out more about the International Engineering Consortium, including the free online education program at www.iec.org's military standards, MLISTD, are maintained with the Defense Supply Center in Columbus, which is field of activated defensive logistics agency with the purpose to provide logistics and contract management support to the U.S. Armed Forces. Department of Defense developed the procedure for the incredible amount of the material for the engineering for the primary contractors, military standards set for the communicating standards, and how things are to be designed, built, and tested and controlled, known with the acceptable manner so that everyone binds bids on the contracts now and not knows exactly what is expected of them, so they are successful competitive. In recent years, the specialized military standards have replaced with the commercial standards such as the IPC standards for the PCB design. Manufacturers for many fields of the engineering, manufacture, ASME, etc. So military standards are becoming obsolete, but the new commercial standards are based on an update with the old military standards. For example, the newer IPC 22221A PCB standard originated with the military standard 275. You can obtain many of the old and military standards for the DSCC website, DSCC DLA mil programs mil spec doc search ASP. American National Standard Institute, or ANSI. American National Standard Institute is private nonprofit organization administered by the coordinated volunteer of the Center for the Standardization Conformity Assessment of the United States. The organization may become accredited by the American National Standard Institute, which signifies their procedure for the American National Standard Institute requirements for the due profit. There are a couple of PCB with electronic design standards that produced through the joint effort between ANSI and other design standards. See IEE below, and you can find them about the ANSI at ansi.org. Institute of Electrical Electronics Engineers. The Institute of Electrical Electronic Engineers has developed a technology standard for the design to build with the consensus and with the open base for the process input with the interested part of the Institute of Electrical and Electronic Engineers, the central source for the standardization field of the telecommunication power generation. Examples of the Institute of Electrical and Electronic Engineers standard related to the schematic design PCB layout, including the IEEE, ANSI 315-1975 graphic symbols, electrical and electronic diagrams, IEEE 1445-1998, and IEEE standard digital test informational interchange format, respectively. www.iee.org. Classes and types of PCB. The design approach of the PCB depends on the manufacturers, including the intended use of the design, fabrication complexity, acceptable the fabrication along with the type of the component attachment technology. Standard classifications have been established with the aid of the designer and fabricated with the consumer with the communication with each other on these issues. The classification include the performance class, productivity level, the type of the class instruction. Performance classes. PCBs can fall into any of the three end-use performance classes throughout with the IPC standards, IPC 7351, Section 1.3, with the IPC D330, Section 11426, IPC CM 770, Section 1, 2, and 1. Material performance for the tolerance level to determine the class rating. Performance classes are based on things that allow the variation. Copper plate with thickness for feature, location, tolerance, hole diameter. Tolerance is played with the unplated name of the view, but the three classes are as follows. General Class 1. General electronic products include the general consumer products of the television, electronic game, with a personal computer. They are not expected to have the extended service life, but they are not likely to subject to extensive test and repairability requirements. Class 2. Dedicated service electronic products products and commercial or military products that have specific function for the communication, instrumentation, sensor systems from which high performance is expected with a longer period of time, since the items are either the higher cost or they are either irreparable but must be with a stricter testing requirements. In Class 3, you have the high reliability electronic products, including commercial military equipment that has been be highly reliable under a wide range of environmental conditions. Examples include critical medical equipment and weapon systems that are typical that have the more stringent test specification, post-process greater environmental robustness and reworkability. Productivity levels were introduced in Chapter 3 that describe the more detailed levels, not so that the explicit requirements, but way of describing how the complex design and the precision required to produce particular forms of the PCB assemblies. Smaller features are trace widths and the extension for the required stricter tolerance to increase the design complexity. IPE standard IPC 7351 Section 131, IPC CM 7070E Section 122, IPC 3330 Section 11426 provides several tables to assist the designer detail with the complexity is related to the standard fabrication assessment. For example, to the issue of the tolerancing connecting lands over the conductor with the tolerances described in the standards for their three productive levels are level A, general design preferred complexity, level B, moderate design standard complexity, and level C, higher design reproduce productibility complexity. Fabrication types and assembly subclass. The PCB, the fabrication types for the IPG 770E with the section 1, 2, and 3 indicate with the number of the higher with the number, the greater the sophistication required with the make of the board. Distributed layer relate with the fabrication type with the number of the copper layer, single layer, two layer, with the multi-layer with the type of the V with the connect with the layer with the fabrication type with the defined with the institute printed circuit boards are type 1 single side with the printed board, type 2 double side with the printer board, type 3 multi-layer printed board without blind or buried Vivas, type 4 multi-layer printed board with blind or buried visas, multi-layer metal core printed board without blind or buried visas, and type 6 multi-layer metal core printed board with blind or visas. Each PCB can take and be further defined as an assembly subclass with a describe how the component attached for the board. IPCC 770E section 122 the subclass is valve subclass A with through-hole devices, THE only, subclass B, surface-mounted devices, SMD only, subclass C, mixed thorough-hole devices with surface-mounted devices, and subsex X, complex thorough-hole devices with surface-mounted devices, fine pitch, BGA packages, class I, thorough-hole devices and surface-mounted devices, complex, ultra-fine pitch, chip sale packaging, subclass Z, complex thorough-hole devices, surface-mounted devices, fine pitch, flip chip packaging. Typically a more sophisticated type of the subclass requires stricter tolerance, predictability level, the higher performance class 4 with the made reliable, using the stricter productability level and lower fabrication types of assembly classes. Orcad layout design complexity level the IPC Institute printed circuit board performance classes. Table 4.1 show the basic printed circuit board characteristics we'll be dealing with and spoke with the relation between the Institute printed circuit board classes and layouts complexity levels given in Appendix A. Class A has the number of layers A with a conductor width of the 12, internal 12, external 16, conductor spacing at 12, annular rings of A internal at 8, and external at 10. Class B has a number of 12 layers, a conductor width 8, internal 10, external 8, and conductor spacing internal annular ring of 5, and 8 is external. Class C has a number of 20 layers and internal and external conductors width at 4, and conductor spacing at 4, annular ring of internal at 4, and external at 5. Institute printed circuit board land pattern densities to level the density level due to the gauge of the PCB footprint land pattern design with regard to how the density of the board can be populated with regard to difficulty with the tracing routing fabrication more discussed in Chapter 5 as to how this relates with the footprint design layout. The three Institute Professional Institute of Printed Circuit Board land pattern density level the IPC 7351 Section 1.4 are density level A with the most land protrusion, largest courtyard, and least density level B, nominal land protrusion, medium courtyard, medium density, and density level C, least land protrusion, small courtyard, high density. Introduction standard fabrication allowances. No manufacturing profit is perfect, therefore subject to the tolerance limitation. PCB, the manufacturer is no exemption to the design tolerance, including the drill hole, location of the dimension and diameter of the copper plate, with the etching, with the solid mask, with the resolution, the name of the few. Manufacturing tolerance becoming increasingly important with the number of layers, increase with the line width, with the space, with the degree of the tolerance area, with the can add up to each of the manufacturing steps, the result of the scrap in a scrap board. It's important with all of the manufacturer limitations so that they will, within the boundary of the manufacturer capability, the industry standard exists with the minimum performance of the process of the guideline, with the individual manufacturers also have their own capability, with the end you need to be aware of them as well. Just because your design meets with a certain minimum industry with standards does not mean that every manufacturer has the ability to manufacture or assemble the PCB as designed. The following discussion covers the major design issues to look at over the reference with the appropriate standards. Registration tolerances, as described in Chapter 1, is made with the step of the design file with the required to fabricate multiple PCBs, design parameters, each for the step to have the line width of the next of the misgeneration can occur, with which can result in the manufacturing defect with a non-operational board. One of the PCB's most vulnerable spots is the plated through hole because it requires accurate alignment with the many layers performed over several manufacturing steps. You break out annular ring control. Figure 4.1 shows the fabrication line with the result of the fine with the hole tolerance. Figure 4.1a shows the ideal hole with the specified with the diameter. Location 4.1b shows the uncertain with the final hole with the diameter with the drilling tolerances. Figure 4.1c shows the uncertainty hole. Location 4.1d shows the desired hole compared with the possible with the hole with the considered with the combined uncertainties. Feature dimension, each of the layer of the PCB have the uncertainty which when combined can result in a bad board if allowances are not designed into the board. In addition, with a higher hole tolerance for their tolerance over the trace land location size due to plate thickness and variation of each of the rate and with the consistency with the combination of these. Alright, 4.1 show the example of the fabrication tolerance and dimension of the uncertainty. Uncertainty can result with the problems such as the loss of the angular control of the subsequent land breaks for the shown in the figure 4.2 with the columns of the 2001 page 42.2. Played with the holes of their function with the will break out with the reliability greatly reduced, and with the by knowing limits of the fabrication profit the following designs you can greatly reduce the occurrence of the defects and increase yield. 4.2 show the breakout plated for the hole due to the misalignment. The ideal plated through hole, plated through break hole. Ideal plated through hole, breakout. Print circuit board dimension. The tolerance of the following section briefly introduce the design limitations you should be aware of. Standard panel size. There are 16 industry standard board panel sizes per IPC with D32 to IPC 2221A, figure 1, page 28. Boards are identified with a letter and a number to represent the X and Y dimension size of the range of the A1 to D4 as shown on the table. The 4.2 with examples of the size C2 panel is listed in the table. C2 is a 7.1 by 6.7 inch. Be aware that standard panel size may help to reduce the cost size. If the smaller of the PCB, the design can be panelized with one larger panel. If flexibility specified on the side of the board, you can do it in a way that allows you to maximize the number of the boards on the panel. This helps to reduce the cost, minimize the number of the parts that are being handled with the amount of waste generated. It is not always an option. The PCB size is often driven by a design constraint. Alright, so for the standard copper clad panel sizes, you have letter A, B, C, and D, and the numbers 1, 2, 3, and 4. They are out there. Some most boards may have the panelized through, but they be assembled inside an automated process since automated machinery is minimum size limitation and a maximum as well as size of the PCB that you can approach will be in Chapter 11 on how to panelize PCB design using the Gerber tool. Tooling area and allowance effect for the panel use of when manufacturer the make of the PCB the name of the to have the area around the PCB outline plate with the tooling hole with the grade with the manufacturer data mark with the shawl code with the tooling area with the required tooling area ranging from 0.375 to 1.5 inches, typically 1 inch. This is measured from the edge of the board outline panel board with the IPC D32 with the panelized design distance between the board, typically from 0.1 to 0.5 inch of the goal is utilized as much of the panel as possible without having to go to the next larger size. IPC D33 section 2 table 2 6 page 9. Most of the time of these considerations handle the board manufacturer transparent with the board design, being aware of the issues may allow with the optimize of the board layout reduce the production costs. Standard finished PCB thickness as described in Chapter 1. PCB is an assembly of one or more cores joined together in a sheet, particularly with a core epoxy called pre-preg. By stacking combination of various core thickness for the sheet of the pre-preg wide variety of finished board per thickness can be achieved in the table 4.3. 4.3 shows the typical finished board with inches, millimeters, and millimeters. Look for the typical board thickness within the industry. The following section discover the core with the pre-preg with the core thickness with the tolerance for the unleavened the design control of the impediment of the PCB, but they not immediately control with the discussion each of the thickness described below with the information presented with the completeness for the reference for the carriers through those for the interested in design control the impedance PCB that can be used when working with layout stack up at the edge of the which discussed in Chapter 9. Core thickness are made over the substrate with a fully covered laminated epoxy which are plated with a copy of the one on both sides of the table. The 4.4 show with the typical laminated epoxy the thickness without copper cladding or foil thickness as described below. Show the millimeter and ranges of the range and averages. And that's your typical laminate core thickness without copper. Pre-preg thickness, 3-preg, that is sheet with the joint with the plate with the cores with the joint with the PCB and stack up with the comes in with the sheet with the various thickness of the table. 4-5 show with the various pre-preg types of the sheet thickness before occurring. Combs 2001, table 6.3, page 6.0, table 10.2, page 2.10.4. 10.4. Board manufacturers stack with a combination with the option for the desired board thickness with the actual thickness for the sheet. With the ones if it is in a board curve depends on the way it is between playing with a single layer because single layers tend to sink into the pre-preg with the result of the thickening and thinner and thickness with the dielectrical constraint and constant of the pre-preg also vary with the manufacturer discussed in Chapter 6. Copper thickness of the plate. Thorough holes vivas. Electroless copper plating is used with the plate holes to make for the plate through holes. Vivas with the drilled holes plated some of the external surfaces that are plated with the thickness of the plating is shows the standard pre-preg thickness, typically 200 to 100 micro inches, both on the whole surface, depending on the board manufacturing process. IPC 2221A, table 4.3 comes to page 28.8. Later in the fabrication process, other plane process is used with the finish of the board. After the finishing process complete with the external surface of the PCB can be much thicker, but the wall thickness of the PTH is usually 1 mil or less. Most of the time, due to the not enter the drill size calculation left, the holes are very small, but the most finished hole sizes are 8 millimeters or larger. But information presented with the completeness of the table 4.6 show the minimum PTH wall thickness presented in the literature of the IPC 2221A table 4.3. Table 4.6 show the minimum electroplating thickness surface and holes, average and thin, classes 1 millimeters and class 3 milliliters and copper cladding foil thickness. When you order a PCB manufacturer, you need to know how thick you want the copper to be. The thickness of the copper depends on how current the tray will require with the carry without the reported impediment with the tray with the copper and controlled impediment with the PCB. Thickness also play with the narrow of the trace can be because of the thicker copper takes longer to etch and can result with a variation in the track width and etch back effects of the described below. Mentioned above with the various finishing process of the etching and plating. Alter with the final cladding of the foil thickness of the process are described in detail. The IPC standard and combs are not described in the table of 4.7. Show the copper thickness and the weight and the gauge is described in literature as in Combs 2001, table 5, 4, 5, 11, IPC D33, section 2, table 216, IPC 4101A, table 1, 2, page 3. Value listed here are the references only and show the nominal finished copper thickness, weight, and gauge, average ounce or foot squared, nominal thickness, internal minimum thickness, finished thickness, and external minimum finished thickness. Copper trace etching and tolerance. Copper is etched instead of the middle of the edge of the copper tray with nearly complete with a smooth and nor vertical wall with a rough curve of the edge of the definition occurs because of the mass resolution limitation, non-uniformity, fast circulation, gas bubbles doing with the etching, etc. The wall will have a slight angle with the recover the acid begins to work with the infinitely exposed the copper to the sidewall begins form who also attack with the high acid with the figure 4.3 show with the copper near the each edge near the edge of the resist begins to be removed under the mask. This is effective called etchback or undercutting the etching process to stop as soon as the last bit of the copper clad over the foil is removed with the surface of the board trace width of the bottom between the initial side of the mask width is defined by the Gerber file for this read of the wire value. W is not lowercase w. Figure 4.3 with the design calculation of the tray the width dimensions are required. Alright, for each show, the result of the finished straight with width due with the etch pack. You have your copper trace. Your FR4 is this etch resistant. Width and edge and W and W in the other etch pack. With the tolerances specified on the table 10.3 with the IPC with the 2221A with the page 78 with a range from positive to negative 4.0 with the mils with the positive negative 0.6 mils for 1.5 ounce of the copper depending on reducibility level of the plating. With the designer should be aware of the width of the variations with the calculating the trace width of the control with the impediment with the current handling ability. General design consideration traces shall be made within practically IPC 2221A minimum trace width spacing 3.9 mils. The individual board manufacturers may have their own etching spacing tolerance. Typical minimum traces width 4 to 8. Good idea with the call. Ask why the capabilities are aired to check with the website. Standard hole dimensions. Holes are drilled into the PCB with the various technique that include the twist bits with the router bits laid with the plasma capability with regard to the placement on the side with accuracy speed that can vary considerably. But the board designer needs to know what size of the drill the hole specified with the pad stack with the standard drill bit size with the specified with the ASI B1911 to M. However, not all board manufacturers carry every size bit. We can specify the particular hole size of the manufacturer have a different way of adjusting it to fit the capabilities, so may round up and down with the nearest drill size available. There must also always be a round up the next largest drill to make sure that the hole is never too small, but the effect of the angular ring of the width can lead to the breakout described in the IPC D3310, 330, section 2, table 2.4 with the list of minimum plate hole size of the board thickness classes. When laminate materials are drilled, they become soft due to the friction heat with the soft laminate and smear with the during with the drilling profit which cover the surface of the copper and with the can prohibit the good plating combs paid to be 10 7 with the 12 of the problem of laminated inside of the hole with the attached back. If they're being drilled with the smear of the hole with the etch back enhances the plating of the PTH plating through holes. Success with the edge pack can cover the partial delimitation internal shorts with the combined with the misregistration make up the hole larger than requested. This is one reason why adequate clearance is required between the plate through the hole plated through a hole and the ground plane is needed. Comes 17.9. After the hole is drilled with the smear with this plate with it depending on the manufacturer's plate with the method the process of the plating can be as much as 1 mil thickness with all the surfaces, which means the diameter of the hole could be as much as 2 millimeters smaller than the specified drill diameter. Pad stack drill size layout is actual drill size but not finished. Hole size in the most cases vary, and so the available drill bit side of the plating is not a problem. But if the holes are very small, with the lead of the diameters are very close with the side of the drill hole for the hole, variation can lead to not fit with the through the hole through hole. Pad stack calculation with the count for the plating of the widths and the tolerance described in the next chapter. Another problem that we can occur with it is that holes have a very small compared to the thickness of the board plating. Profit may be satisfactory with the proper hole diameter of the PCB width. It's called the aspect ratio. Your aspect ratio is the ratio plated hole diameter of the PCB thickness recommended for the AR between 3 to 1 to 5 to 1 of the level A boards, and 3 to 1 being good target. AR for level B boards is 6 to 8 to 1. Level C boards may be this high as 9 to 1 higher. Check with the board manufacturer to know what the capabilities are because of the aspect. Ratios too high, plating problems can occur with the inside of the hole, which can lead to the opening circle with the incomplete plating and barrel cracking. Pad stacking design includes all issues described above that is covered in detail in Chapter 5 and 8. Solid mass tolerancing. Due to photolithograph with the misregistration, as well with the solid mass lands, and with the partial couple of solid mass pattern with the solid plated lands. Plated lands may be the damage when the solid reflow with doing the solid operation will adversely affect with the solderability. This may be expressly troublesome in the very small parts of the SRT, the 23, with reduce the risk of the side of the mask opening often layers larger than the lands with oversized. There are two basic categories of solder mask materials: liquid screen printed with the photo image mask. The recommended oversight of the liquid screen printing coating is 16 to 20 mils. The recommended oversight of the photo image mask is 0 to 5 mils. And many of the layout footings have then clearance between 0 to 5 mils. Many fabricators suggest the solder mask is described as necessary for this process. However, some do not accept it or assume that you will do it. Check with your board house to find out that you require oversizing. If so, how much and why, what they expect to do. End note: suggested reading. The highest suggested new PCB designers is given below, with the more list of given in appendix I, B. The Institute of Printed Circuit Boards 2221A, generic standard printed board design. Military 2275, printed circuit board electronic equipment. IPC 7351, general requirements, surface mounted design and land pattern standards. IEEE ANSI 315, 1975, graphic symbols, electrical, electronic drawings. Military Handbook 198, selection use of capacitors. Military Handbook 199, use of resistors. Other items of interest: the ASM AB18 series standard for the mounting hardware. Military Handbook 5961A, list of standard semiconductor devices. ASI IPC D32 guidelines of selecting printed wiring board sizes using standard panel sizes. Military Handbook 1861, selection use of electrical electronic assembly boards, cards, and associated hardware. Title 47. Federal Regulation 15, FCC rules on radio frequency devices, including unintentional radiators. Free download. Chapter 5, Introduction to Design for Manufacturing.